Hello everyone, my name is Nana and I'm from the Buddhi Academy. So today we'll continue with the chapter that is Organic Chemistry, some basic principles and techniques. Now in today's video we will continue with the part of methods of purification of organic compounds. Now in this we have 5 different methods: sublimation, crystallization, distillation, differential extraction and chromatography. And these are the 5 techniques which are used to purify organic compounds. Now, methods of purification of organic compounds. Once an organic compound is extracted, from a natural source or synthesized in the laboratory, it is essential to purify it. Now, natural source, you don't know what all components are there in addition to your organic compounds. Now, the one which you synthesize in the laboratory, you know what are the chemicals that you have added, right? So there will be some byproducts. As all these reactions you have seen, there are byproduct, intermediate products. Now to purify your compound from all those unessential byproducts is necessary. Now how you will purify it? Now various methods used for purification of organic compounds are based on the nature of the compound and the impurities present. Now to choose a particular method or technique to purify your compound, that will basically depend upon the nature of the compound. If your compound is heat sensitive, then you won't be able to heat it. So sublimation is not possible because in sublimation you heat the compounds. Now if your compound is highly reactive, then you can't do any of this because it will react with any of the molecule that you add for purification. And it also depends upon the impurity. If the impurity and your molecule, your organic compound, is quite similar, the difference is not huge, then you can use differential extraction to separate them up. So depending upon the compound and the nature of the impurity or the impurity which is present in it, you can choose any of this method for your separation or purification. Now the common techniques which we use are sublimation, crystallization, distillation. Sublimation, crystallization, distillation, differential extraction and chromatography. Amongst this, chromatography is the most common one. Now finally, the purity of a compound is ascertained by determining its melting or boiling point. Now once you purify your compound, how will you confirm that your compound has been exactly extracted without any impurities or without any byproducts? Now that determination is done by melting or boiling point. Now most of the pure compounds have sharp melting points and boiling points. New methods of checking the purity of an organic compound are based on different types of chromatography and spectroscopic technique. Nowadays we use chromatography and spectroscopic techniques to identify the purity of the organic compound, but initially it was done using by determining the melting and boiling point, because all of the pure compound, without any impurities, the pure compounds, they have a very sharp melting and boiling point. At that particular temperature it will melt or it will boil. Now we use chromatography and spectroscopic techniques to determine the purity. So let's start with the first technique, that is the sublimation. Now you have learned earlier that on heating, some solid substances change from solid to vapor state without passing through the liquid state. Now what is sublimation? Sublimation is the technique from which you convert your solid into gas without converting it into a liquid. A simple example is your camphor. Camphor, when you burn it, before burning it is a solid tablet kind of thing. That moment you burn it, it will convert from solid to a vapor, a gas kind of thing, right, without converting it into liquid. So that is what sublimation is. Now the purification technique based on the above principle is known as sublimation, and it is used to separate sublimable compounds from non-sublimable impurities. Now where this technique is used, this technique is basically used for separation of those compounds which can directly be converted from solid to a gaseous form if the impurities present in them are non-sublimable. If the impurities, they doesn't convert solid to vapor without converting into liquid state, in that case you can use sublimation for your separation. Now, next one is the crystallization technique. This is one of the most commonly used technique for purification of solid organic compounds. Okay, crystallization is basically used for the purification of solid organic compounds. It is based on the differences in the solubilities of the compound and the impurities in a suitable solvent. Now, crystallization, it is based on the difference in solubility. Okay, who is more soluble than whom? Okay, it is just based on the difference in solubility of the compound and the impurities in a suitable solvent. Now, the impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at high temperature. Now, the impure compound, that is your impurity, your compound with impurities. So, the impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature. Okay, sparingly soluble means partially soluble at room temperature but appreciably soluble at higher temperatures. Now, the solution is concentrated to get a nearly saturated solution. On cooling the solution, pure compound crystallizes out and is removed by filtration. Okay, so whenever you do crystallization technique, okay, you dissolve your impure compound, your compound with impurities in a solvent in which your compound is sparingly soluble at room temperature. Sparingly means it doesn't completely soluble at room temperature, but the moment you heat it, your compound, your desired compound is dissolved completely. Okay, now this concentrated solution, it get nearly saturated. Okay, on cooling, okay, the solution on cooling, your compound which was dissolved will get crystallized. Okay, and this crystallized solution is filtered. Now the filtrate is called mother liquor. Okay, the liquid which we get at the bottom, we call it as mother liquor. Now, which contains impurities and small quantity of your compound, because your compound has crystallized and it is on the filter paper. Now whatever solution you get at the bottom, that is your mother liquor, and that mother liquor contains your impurities and your small quantity of compound, because not everything is dissolved. Okay, so if the compound is highly soluble in one solvent and very little soluble in another solvent, crystallization can be satisfactorily carried out in a mixture of these solvents. Okay, if your compound is completely soluble in one solvent and partially soluble in other solvent, then you can mix both the solutions and then you can carry out the crystallization process. And in this mixed solution, you can add your compound and dissolve it. Now, impurities which impart color to the solution are removed by absorbing over activated charcoal. Now, when your impurities, they impart color, they give color to your compound or your solution. In that case, you add activated charcoal to that solution, and this activated charcoal remove or absorb the colored impurities. Now, repeated crystallization becomes necessary for purification of compounds containing impurities of comparable solubilities. So, when you have your compound and the impurity with almost similar solubility, or the difference between their solubility is not great, in that condition repeated crystallization is necessary to confirm or to make sure that your compound is completely purified. Next is the distillation process. Now, this important method is used to separate. Now, where we use distillation process? Distillation process is used to separate volatile liquids from non-volatile impurities, and second one is the liquids having sufficient difference in their boiling points. Now, distillation process, you can use them in two conditions. First one is when you have a volatile liquid and a non-volatile impurity. Now, what is volatile? Volatile means the moment you keep it outside, it evaporates or it catches fire. Okay, such are volatile liquids. And when you can separate out volatile liquids from non-volatile impurities. Or second thing is the liquids which have difference between their boiling points. Okay, Now, different liquids having different boiling points vaporizes at different temperature. Now, the vapors are cooled and the liquid so formed are collected separately. Now, the ones where we use boiling point, difference between boiling points of the liquid as a method, the liquids having different boiling points, they will form their vapors or they will vaporize at different temperatures, and these vapors when collected and when we condense them, they are collected in the separate vessels, okay, condensing to liquid, and we collect them in separate vessels. For example, chloroform and aniline. Chloroform has a boiling point of 334 Kelvin, whereas aniline has a boiling point of 457 Kelvin. Are easily separated by the technique of distillation because of their difference in boiling temperatures. One is 334, another one is 457. But if we look at it like this, the difference is not bigger, right? But if we convert the Kelvin into degrees Celsius, you can make out the difference. For example, 334 Kelvin. How you convert Kelvin into degrees centigrade? You subtract it from 273. So this is 61 degree. No, 457 minus 273. This will be 4. Okay, so the temperature difference is 61 degrees centigrade and 184 degrees centigrade. So you can see the difference, right? 61 and 184. Now this is easily be separated because chloroform will vaporize at 61 degrees centigrade, whereas aniline will vaporize at 184 degrees centigrade. Okay, so once you set the temperature at 61 degrees centigrade, you can convert all the chloroform into vapors, then condense it using a condenser and collect it into a conical flask and separate out. Later you can raise the temperature to 184 degrees centigrade where you can separate out your aniline. Okay, now the liquid mixture is taken in a round bottom flask. Now how you will do? So you have to take a round bottom flask and heat it carefully. So this is the round bottom flask. In this round bottom flask, take the solution, mixture of solution, that is your chloroform and aniline. Okay, the mixture of chloroform and aniline is taken into this round bottom flask and this is heated carefully. See, this is the burner, so it is heated carefully. Now when the temperature is at 61 degrees centigrade, your chloroform will start converting into vapors. Now on boiling, the vapors of lower boiling component are formed first. So here the vapors of lower boiling component, that is your chloroform boils at 61 degrees centigrade. Now the vapors of chloroform will start forming. Once those vapors are formed, they are collected into this small tube and this tube is called condenser. Okay, now this condenser is constantly supplied with cold water because the vapors are hot, right? So the moment it enters the condenser, it is supplied with a cold environment where it gets condenses, okay, from vapor to liquid, and that liquid is later collected here. Okay, this is how we distillate the mixture of solution with their various or with the difference of their temperature. So at 61 degrees centigrade, all the chloroform will distill out. Then at 184 degrees centigrade, okay, your aniline will start boiling up. Now the vapors are condensed by using a condenser and a liquid is collected in a receiver. So this is a condenser and this is a receiver. Now water inlet and water outlet. So you have to connect the condenser into a continuous water supply. So the cold water will remain as it is and the hot water will be removed from this end. Okay. Now the vapors of higher boiling component form later and the liquid can be collected separately. Okay, now this is the simple distillation unit. Next one is the fractional distillation. Okay, If the difference in boiling point of two liquid is not much, simple distillation cannot be used to separate them. Okay. Now, simple distillation we can use when there is a vast difference between the boiling point of the two liquids. Okay. But if the boiling point of two liquid is not much, they are very close to each other. In that case, you can't use a simple distillation technique, because if you use a simple distillation technique, both the solution will start vaporizing at the same temperature or nearly the same temperature. At least not completely, but partially it will vaporize. Now in that case, the vapors of such liquids are formed within the same temperature range are condensed simultaneously. So if you do a simple distillation, they will be condensed simultaneously. Hence, to avoid that, we use a technique called as fractional distillation, where we collect them in fractions and we re-distill them until we get a separate isolated solutions. Okay. Now the technique of fractional distillation is used in such cases. In this technique, vapors of liquid mixture are passed through a fractionating column before condensation. Now the fractionating column is fitted over the mouth of the round bottom flask. So on this setup, there is another thing added for fractional distillation, and that is your fractionating unit. Okay, now what is a fractionating unit? We will see it down in the diagram. Now vapors of liquid with higher boiling point condenses before the vapors of liquid with lower boiling point. Now the vapors rising up in the fractionating column becomes richer in more volatile component. So this is the fractionating unit. Okay. Now what will happen is the vapors of a liquid with higher boiling point condenses before the vapors of liquid with lower boiling point. Now the vapors rising up in the fractionating column become richer in more volatile component. By the time the vapors reach to the top of the fractionating column, these are rich in the more volatile component. Fractionating columns are available in various size and designs. Okay, so whenever you have a fractionating column, okay, the vapors of liquid with higher boiling point, they condenses before the vapors of liquid with lower boiling point does. So the condensation process of the vapors with higher boiling point is faster than the ones with lower boiling point. Now the vapors that rise in the fractionating column before fractionating column becomes richer in more volatile component. Okay, now by the time the vapors reach to the top of the fractionating column, these are rich in the more volatile component. Now fractionating columns, they are available in various sizes and designs. Now fractionating column provides many surfaces for heat exchange between the ascending vapors and the descending condensed liquid. Now some of the condensing liquid in the fractionating column obtains heat from the ascending vapors and revaporizes. Now the vapors thus become richer in low boiling component. The vapors of low boiling component ascends to the top of the column. On reaching the top, the vapors become pure in low boiling component and pass through the condenser, and the pure liquid is collected in a receiver. Now when you have a fractionating column which provides more surfaces to the vapors which are coming up and the ones which are coming down. Okay, so whenever you have a vapor, you have two liquids, right? Both are with similar boiling points, or both falls under similar range of boiling point. When one of them, the one with higher boiling point, it vaporizes and it goes on top, it will condense and come down. The one with lower boiling point will slowly start coming up, and the time it comes up, okay, the high boiling point ka vapor of the molecule with high boiling point will condense and come down. That condensation will have still heat in that, and that liquid will re-vaporize your low melting point ka compound, and that vapor will rise higher and higher, and it will reach to the point where it will start moving into the condenser and then condenses. So the ones with lower boiling point will will be removed first. Okay. Now, after a series of successive distillation, the remaining liquid in the distillation flask gets enriched in high boiling compound. So this will go on, this will keep going on. So the one with higher boiling point will go on top, it will condense and come down. It will condense in between these beads and it will start coming down. And your low boiling point vapors, it will start going up and it will re-vaporize by the condensed liquid which is coming down. Okay, because of that condensed liquid which is coming down through these beads, your vapor from the lower boiling point will re-vaporize and it will start going on top and top and top, and then it will be separated into the condenser, separated funnel, and in the round bottom flask eventually your high boiling point solution will remain. Okay, each successive condensation and vaporization until in the fractionating column is called the theoretical plate. Okay, now each successive condensation and vaporization unit in the fractionating column is called the theoretical plate. Now commercially columns with hundreds of plates are available. One of the technological application of fractional distillation is to separate different fractions of crude oil in petroleum industry. Okay, now fractional distillation, one of the most important use of fractional distillation is in the crude oil form. Okay, crude oil in petroleum industry. Now distillation under reduced pressure. When you have distillation under reduced pressure, this method is used to purify liquids having very high boiling point and those which decompose at or below their boiling points. Okay. Now this method is used to purify liquids having very high boiling point and those which decompose at or below their boiling points. Now such liquids are made to boil at a temperature lower than their normal boiling points by reducing the pressure on their surface. Now how such liquids are made to boil? They are made to boil at lower temperature. Okay, temperature lower than their normal boiling points by reducing the pressure on the surface. Now a liquid boils at a temperature at which its vapor pressure is equal to the external pressure. Now when a liquid will boil, it will boil at a temperature when its vapor pressure and the pressure which is outside is equal. Now the pressure is reduced with the help of a water pump, okay, or vacuum pump. Using vacuum pump or water pump, the air which is there in that system is removed and a vacuum is created which reduces or which increases the pressure, and this pressure increase will reduce the boiling point at that particular temperature. Now, glycol can be separated from spent lye in soap industry by using this technique. So this technique is basically used in soap industries to separate out your glycerol. So this is what your distillation under reduced pressure looks like. Next one is the steam distillation. Distillation using steam. This technique is applied to separate substances which are steam volatile and are immiscible with water. Okay. Now in steam distillation, steam from a steam generator is passed through a heated flask containing the liquid to be distilled. Now the mixture of steam and the volatile organic compound is condensed and collected. Now in steam distillation, what happens? A steam is passed from a steam generator through a heated flask containing the liquid to be distilled. The mixture of liquid that you want to distill out, to that liquid, a steam is passed through a steam generator. Now the mixture of steam and the volatile organic compound is condensed and collected. So the steam and the volatile compound, organic compound, they are condensed together and collected. Now the compound is later separated from water using the separating funnel. Now in steam distillation, the liquor boils when the sum of vapor pressure due to the organic liquid and that due to water becomes equal to the atmospheric pressure. Okay. Now steam distillation. In steam distillation, the liquid starts to boil when the total vapor pressure, okay, due to the organic liquid and due to water, okay, both the vapor pressure due to organic liquid and vapor pressure due to water becomes equal at atmospheric pressure, that is P is equal to P1 plus P2. Now since P1 is lower than P, the organic liquid vaporizes at lower temperature than its boiling point. Now Thus, in one of the substance, thus if one of the substance in the mixture is water and the other a water insoluble substance, then the mixture will boil close to but below 373 Kelvin. Okay, 373 Kelvin means 100 degree, almost 100 degree Celsius. Now, a mixture of water and the substance is obtained which can be separated by using a separating funnel. Now there is something called as separating funnel. This is a steam distillation. Okay. Now this is what separating funnel is. So you get a solution of your distilled liquid and water. Now this can be separated out using the separating funnel. This is before extraction and this is after extraction. Now, steam distillation, you can get an example is aniline. Aniline is separated by this technique from aniline water mixture. Now, next one is the differential extraction. Now, when an organic compound is present in an aqueous medium, it is separated by shaking it with an organic solvent in which it is more soluble than in water. So when you have an organic compound which is present in aqueous medium means which is present in water. In that case, you take a solvent, organic solvent, in which your compound, organic compound is more soluble than water. Okay, so what will happen? Your compound, which is partially soluble in water, will get completely dissolved in the organic solvent that you have added. Now, the organic solvent and the aqueous solution should be immiscible with each other so that they form two distinct layers which can be separated by separatory funnel. So whenever you choose a organic solvent for the separation in differential extraction method, the organic solvent should not mix with water. They should have a clear distinction like oil and water. Okay, so they should have a clear distinction between them. Now the organic solvent is later removed by distillation or by evaporation to get back the compound. So what you have to do is, if your compound is present in water, then you have to add a solvent, organic solvent, in which your compound is more soluble than in water. But you have to choose the organic solvent in such a way that that organic solvent does not mix with your water. There should be a clear distinction. So in that case, what will happen? Your compound will dissolve in your organic solvent and water will remain like that. Then you can use a separatory funnel to separate out the solution, your organic solution containing your compound. And that organic solution, once you treat it for distillation, you can get your pure compound. Now differential extraction is carried out in a separatory funnel. Okay, so this is the separatory funnel which is used for the process of differential extraction. Now, if the organic compound is less soluble in the organic solvent, a very large quantity of solvent would be required to extract even a very small quantity of the compound. Now, if your organic compound is less soluble in your organic solvent, then a very large quantity of solvent would be required to extract even a very small quantity of the compound, because the more solvent you add, the more compound will be dissolved in it. Now, the technique of continuous extraction is employed in such cases. So in such cases, you use continuous extraction. You add little solvent, you mix it, you drain it. Again, you add little more solvent, you mix it, you drain it. So a continuous extraction process method is deployed here. In this technique, same solvent is repeatedly used for extraction of the compound. So once you know that your compound is only dissolved in, or it only dissolves in this organic solvent, but not completely but partially, then you have to use that solvent for your continuous extraction. The next method is the chromatographic method. Now chromatography is an important technique extensively used to separate mixtures into their components, purify compounds, and also to test the purity of the compounds. Now chromatographic technique has various importance. Okay, so it is an important technique extensively used for the separation of mixtures into their components, then to purify compounds, and also to test the purity of the compound. Now the name chromatography is based on a Greek word called chroma, which means color, and method was first used for separation of colored substances found in plants. Okay, so it was first used for the separation of colored compounds from the plants. Now in this technique, the mixture of substances is applied onto a stationary phase, which may be a solid or a liquid. Okay, so first what you have to do is you have to apply the mixture of substances onto a stationary phase. Okay, and the stationary phase, which may be a solid or a liquid. Now a pure solvent, a mixture of solvents or a gas, is allowed to move slowly over the stationary phase. Then this stationary phase is kept in a pure solvent or a mixture of solvent, or a gas is passed through it slowly, okay, over the stationary phase. Now the components of the mixture get gradually separated from one another. The moving phase is called as mobile phase. The solvent, pure solvent, mixture of solvents or gas which is there, they are called as mobile phase. Now based on the principle involved, chromatography is classified into two categories: adsorption chromatography and partition chromatography. Now, what is adsorption chromatography? Adsorption chromatography is based on the fact that different compounds are adsorbed on an adsorbent to different degrees. Commonly used adsorbents are silica gel and alumina. Now your stationary phase, okay, your stationary phase is called as adsorbent, okay, to which your compounds are adsorbed. Okay, now this stationary phase can be of silica and alumina. Adsorption chromatography, it works, or it is based on the fact that different compounds are adsorbed on the adsorbent at different degrees. Different degrees means at different points. Okay, now this adsorbents can be a silica gel or alumina. Now when the mobile phase is allowed to move over stationary phase, that is when a mobile phase is allowed to move over this adsorbent, the component of the mixture move by varying distances over the stationary phase. So the components, they start to separate out and they start to show their separation at various distances over the stationary phases. Now following are the two main chromatographic techniques based on the principle of differential adsorption. Okay, these are the two main chromatography which are based on the principle of differential adsorption: column chromatography and thin layer chromatography. Now column chromatography involves separation of a mixture over a column of adsorbent, that is your stationary phase, packed in a glass tube. Okay, you have a glass tube like this. In this glass tube your stationary phase is filled. Okay, now the column is fitted with a stopcock at its lower end. The mixture adsorbed or adsorbent is placed on top of the adsorbent column packed in the glass tube. So here your stationary phase is filled and it is stopped with a stopcock, and on top of that you add your mixture that you want to separate, and on top of that you add your mobile phase or your solvent. Okay, now the mixture adsorbed on the adsorbent is placed on the top of the adsorbent. So here you place the mixture which is on top of your adsorbent, and an appropriate eluent, which is liquid or a mixture of liquid, is allowed to flow down the column slowly. Now your solvent, it is also called as eluent. Okay, so the appropriate solvent or eluent is allowed to flow through the mixture of compounds. Now, depending upon the degree to which the compounds are adsorbed, complete separation takes place. Now, depending upon the degree to which the compounds are absorbed. Okay, now here they have used A, B and C mixtures. Now, at what temperature or at what point is your A adsorbed? At what point is your B adsorbed? At what point is your C adsorbed? That particular region, your compounds will start separating out. You have to continuously keep your eluent flowing. Okay, now the most readily absorbed substance are retained near the top and others come down to various distances. Now the ones which is most readily absorbed will remain on the top. For example, A, which is most readily absorbed by your stationary phase, it remains on top, and B and C starts coming down. Okay, so this is what your column chromatography is. And later, if you keep adding the solvent, this will come down and you can collect it first, and then your B will come, you can collect it, then your A will come. So you have to keep adding the solvent till the component comes out. Next one is your thin layer chromatography. Now, thin layer chromatography or TLC is another type of adsorption chromatography which involves separation of substance of a mixture over a thin layer of an adsorbent coated on a glass plate. Okay, basically your slides. Okay, you have slides with a bigger length, not smaller one, the ones which are bigger and thicker. You have to coat them with your silica or a alumina gel, and then the thickness should it should be a thin layer with 0.2 mm ka thickness. Okay, it's spread over the glass plate on a suitable size. Now the plate is known as thin layer chromatography plate or a chroma plate. Now the solution of the mixture is to be separated, is applied on the plate on as a small dot. Okay, which is about 2 cm from the TLC plate. Okay, from the TLC plate about 2 cm you point the solution which you want to separate out. Okay, and then you dip this into a jar containing the solvent. Now this can be a pure solvent or a mixture of solvent. Now as the eluent which start rising up, your point will start separating. Okay, now the mixture move along with the eluent to different distances depending on their degree of adsorption and separation takes place. So as your solvent start moving upwards, the point will also move upwards. Now it will separate out as the degree of adsorption. If your first component is adsorbed here, then second component is here, third component is here. So the degree of their adsorption, they will start distancing themselves and the separation takes place. Now the relative adsorption of each component of the mixture is expressed in terms of retardation factor. Okay, now at what point they are adsorbed, so the relative adsorption we call it as retardation factor or RF value. Now how you will calculate the RF value? This is the formula for calculating the RF value. That is, RF is equal to distance moved by the substances from the baseline. Okay, if this is your slide, here you have your dot, and this is till here my solvent has moved. Don't allow your solvent to go beyond it. Okay, stop it at a point where it doesn't go out of your slide. Now from the baseline to your substance, okay, this is the X value, and from your baseline to the point till where your solvent has moved, this is your Y. Okay, so distance moved by the solvent from baseline and distance moved by the substance from the baseline. So you divide them and you will get the value of RF. Now the spots of colored compounds are visible on TLC plate due to their original color. If you are adding any colored compound, then you can observe them directly with their original color. But if the spots are colorless, okay, if the spots are colorless and you cannot see them using your naked eyes, then you can make them visible by applying a fluorescence in ultraviolet light. Okay, by passing them to UV light, you can see them and can be detected by putting the plate under ultraviolet light. So using UV light also you can make out the points. Now another detection technique is to place the plate in a covered jar containing a few crystals of solid iodine. Okay, you have to put few crystals of iodine into a jar and generate gas of that, and into that gas you place the TLC plate. Then that iodine gas will mark it into a dark orange colored dot wherever your compound is adsorbed. Okay, now the spots of the compound which adsorb iodine will show as a brown spot. Now sometimes an appropriate reagent may also be sprayed on the plate. For example, amino acids may be detected by spraying the plate with ninhydrin solution. Okay, so you can observe the colorless spots under UV light, or by placing them into an iodine gas chamber, or by spraying the gases, okay, in hydrogen solution or any other gas onto the TLC plate. Now next one is the partition chromatography. Now partition chromatography is based on a continuous differential partitioning of components of a mixture between stationary and mobile phases. So partition chromatography, it is based on the continuous differential partition. You are differentiating the components of a mixture between stationary and mobile phase. Okay. Now paper chromatography is a type of partition chromatography. Now paper chromatography that we usually do is a example of partition chromatography. In paper chromatography, a special quality paper known as chromatography paper is used. Okay. Now on that chromatographic paper contains water trapped in it, which acts as a stationary phase. So chromatographic paper, it contains water which is trapped inside it, and that acts as a stationary phase. Now how for TLC use silica gel or alumina gel? Similarly, paper chromatography, it has water trapped in the paper which acts as a stationary phase. Now a strip of chromatographic paper spotted at the base with the solution of the mixture is suspended in a suitable solvent or a mixture of solvents. So you take a strip of chromatographic paper which is spotted with the solution which need to be separated at the base, and then it is suspended into a suitable solvent or a mixture of solvent. Now this solvent acts as the mobile phase. Now the solvent rises up the paper by capillary action and flows over the spot. Okay. Now the paper selectively retain different components according to their differing partition in the two phases. Now the papers which are selective, they will retain the components, okay, which are water soluble will remain on the paper only. The ones which are non-water soluble will start move on top of the solution with the mobile phase. Now the paper strip is also developed, is known as chromatogram. Okay, the spots of the separated colored compound are visible at different heights from the position of initial spot on the chromatogram. Now the spots on the separated colorless compounds may be observed either under ultraviolet light or the use of appropriate spray reagents at under thin layer chromatography. Okay, so if it is colored, then you can spot them directly. If they are non-colored, then you have to use a indicator to spot them, like ultraviolet light or iodine gas, or spraying the components on them. So this is what chromatography. Now these are the techniques that we have seen here. In our next video, we will learn the qualitative analysis of some organic compounds. So thank you for watching my video. Please do like, share, subscribe to our channel.